Hi guys, welcome back to our channel. Today we are going to talk about Math Chapter 2, Algebra, which is all about using letters to represent unknown number. First, note the difference between algebraic expressions and equations. For example, 2 plus x equals to 12, x equals to 12 minus 2, x equals to 10. And the other example, 30 plus y equals to 10, y equals to 10 minus 30, y equals to negative 20. These are called equations. You solve by finding the value that make the equation true. Because you see that x cannot be 8 here, because 2 plus 8 will give 10 instead of 12. I'm sure you all have seen algebra somewhere else, like for example in area of rectangle. This is the length and this is the width. And we all know that area of rectangle is length times width. So in short, it's A equals to L width. Another example, area of triangle is 1 over 2 times its base times its height. So in short, A equals to 1 over 2 BH. So for now we are done with algebraic equations. Let's move on to algebraic expressions. We suppose that the average height of students in your class is an unknown number h. A student who is 10 cm taller than the average will have a height of h plus 10. And a student who is 3 cm shorter than the average will have a height of h minus 3. So these are both algebraic expressions. Because the unknown value is represented by h, we say that these are expressions in terms of h. So given that the average score is C, express a score 20 higher than average. C plus 20. And this would be C plus 3x. A score twice the average would be Z times 2, which is 2Z. A score half the average, 1 over 2 times Z, or Z divided by 2, which gives you Z over 2. So there are actually rules when you write algebraic expressions. They should be written in the simplest way. So 2 times x should be 2x instead of 2 times x. X times 1 should be only x. X divided by 2 would be x over 2. Or x divided by y should be x over y. Now when you have a product of a number and a variable, the number is written first. So 2h and not h2. Also, variables are normally written in alphabetical order. So it should be xy or 2ab instead of yx or ba2 or 2ba. H times h should be h squared. And h times h times h should be h cubed. And note the difference between 5a squared and 5a to the power of 2. Because the number only applies to the number or variable directly before it, so 5a squared would be 5 times a, which will give you 5a squared. 5a squared would be 5a times 5a, which is 5 times 5 times a gives you 5 squared times a squared, 25a squared. Here's some questions. X times 5 should give you 5x. Sum of h and 5 would be h plus 5. 6 less than x would be x minus 6. And do not confuse x is less than 6 would be x less than 6. This would be 4a plus 5b, 3a plus 6 divided by 2b, which would give you 3a plus 6 over 2b. Now let's come to substitution. When you are given a value for the unknown, you should be able to evaluate them. So ab would be a times b, which is 2 times 8, 16. 3b minus 2a would be 3, 8 minus 2, 2, which is 24 minus 4 gives you 20. 2a to the power of 3, 2, 2 to the power of 3, which is 2 times a, gives you 16. 2a times a plus b, 2 times 2 times 2 plus 8, which is 2 times 2, 10, which is 40. It's important that you know how to simplify expressions. Terms are separated. It's important that you know how to simplify expressions. The parts of an algebraic expression are called terms. Terms are separated from each other by plus or negative signs. So a plus b is an expression with two terms. But ab is an expression with one term. To simplify them, you have many ways. When there's a plus or minus in between the terms, and they are like terms, you can add or subtract them. Like 2a plus 4a, you can add them to 6a, or 3xy plus xy would be 4xy, the terms. Or when you are required to minus them, 3xy squared minus xy squared would be 2xy squared. But if it's 3xy squared minus xy, it will still be 3xy squared minus xy. So let's work on some examples. 4a plus 2a plus 3a. This would give you 4 plus 2 plus 3, 9a. 5x plus 2y minus 7x would be negative 2x plus 2y. 2ab plus 3a squared b minus ab plus 3a squared b. This will give you ab plus 3a squared b plus 3ab squared. Because only the like terms can be added together or subtracted together. Before you want to multiply or divide expressions, make sure you understand and remember these important rules. 3x means 3 times x. And 3xy means 3 times x times y. xy means x times y. X squared would be x times x. X squared y would be x times y. 2a over 4 would be 2a divided by 4. If you're confused with note that these are different. Note that 2a over 4 is different with 2 over 4a. 2 over 4a will give you 1 over 2a, which is a over 2. Some examples for multiplying expressions. 4 times 3x would be 4 times 3 times x. 12 times x gives you 12x. 4x times 3y. 4 times x times 3 times y. 12 times x times y gives you 12xy. 4ab times 2bc gives you 4 times 2 times a times b times b times c. So 8 times a times b squared times c gives you 8ab squared c. Lastly, 7x times 4 yz times 3. 7 times x times 4 times y times c times 3. 7 times 4 times 3 gives you 84. Times x times y times c gives you 84xyz. Examples for dividing expressions. 12x over 3, 4, 1. So 4x over 1 would be 4x. 12xy over 3x, you can cross out. 7xy over 70y, get 10x over 10. And lastly, 2x over 3 times 4x over 2. 2 times x times 4 times x over 3 times 2. So 8x squared over 6. So this gives you 4x squared over 3 as they are both divided by 2. When an expression has brackets, you have to remove them before you can simplify the expression. This is called expanding expressions. You do them by multiplying each term inside the bracket by the number or variable outside the bracket. But pay attention to the positive and negative signs in front of terms. These are the 4 examples. When negative times negative, it gives you false. 2 more examples. This will give you 4x plus 4 and 2x, x plus 3y should give you 2x squared plus 6xy. After all the expansion, addition or subtraction, multiplication, you have to remember to collect the like terms, and you do this by adding them or subtracting them to write the expression in its simplest forms. So, for example, this will give you 6x plus 18 plus 4, 6x, add them, 22. These are the like terms. Another example. (12x plus 2 minus 2x plus 4). So give you 10x plus 6. Same here. 2x bracket x plus 3 plus x, x minus 4. 2x squared plus 6x plus x squared minus 4x. So give you 3x squared plus 2x. Now let's come to indices. You already know how to write powers of 2 and 3 using indices in the previous video, where 2 times 2 gives you 2 squared, and y times y gives you y to the power of 3, or y cubed. Index can be any number, including 0, negative integers, and fractions. So, and note what is base and index. Index is the power, base is the number over here. This is base, this is index. Index notation can be very useful because it allows you to write in a short form, for example in factor tree or division method to find prime factors. So for example, 200 gives you 2 times 2 times 2 times 5 times 5. So 200 equals to 2 cubed times 5 squared. Or 10 times 10 times 10 times 10 times 10. This is 10 to the power of 5. So index is actually how many times the number multiplied by itself. Another example, so p times p times p times q times q. So give you p to the power of 3 q squared. First, multiplying the same base number with different indices. So when you look at 3 squared times 3 to the power of 4 and x squared times x to the power of 3, we already know that we can do it by writing 3 times 3 times 3 and so on, x times x times x times x, so on. To do it faster, brought in law indices for multiplication, you can do it in this way. 3x 3 to the power of 4 equals to 3 to the power of 2 plus 4, 3, 6. Here, x squared plus 3, x to the power of 5. As simple as that. So basically, x to the power of m times x to the power of n gives you m plus n, given that the base is the same. So x to the power of m times y to the power of n gives you the same thing. It would not give you this. The next law of indices for division. When you're given 3, 4 divided by 3 to the power of 2 and x to the power of 6 divided by x squared, We know that we can write it this way. 3 times 3 times 3 times 3 divided by 3 times 3. Cross them out. Then you get 3 times 3, which is 3 to the power of 2. And here, x to the power of 4. In a simpler way, we can do it. 3 to the power of 4 divided by 3 to the power of 2 gives you 3 to the power of 4 minus 2, 3 to the power of 2. Same goes here. This is x to the power of 6 minus 2. So in short, law of indices for division tells you x to the power of m divided by x to the power of n is x to the power of n minus n. Now every number power to 0 will give you 1. Anything. Because you remember that any value divided by itself gives 1. So to make it simpler, x to the power of 4 divided by x to the power of 4 is x to the power of 4 minus 4. And this is x to the power of 0. And this basically equals to 1. So any value to the power 0 equals to 1. So x to the power of 0 equals to 1. Law of indices for raising a power to another power. When you're given x3 squared 2x cubed to the power of 4. If you want to do it slowly, you can. x3 times x3 equals to x3 plus 3 gives you x to the power of 6. And 2x3 times 2x3 4 times and will give you 2 to the power of 4 times x3 plus 3 plus 3 plus 3 and gives you 16 times x12. But there is a simpler way to do this. X cubed raised to 2 basically is 3 times 2, which is x to the power of 6. Same goes here. 2 to the power of 4 times x3 to the power of 4 gives you 16x12. So basically, when you have to raise a number to another power, you multiply the indices. xm n gives you xmn. One more, negative indices. When you have x3 divided by x to the power of 5, based on what we learned earlier, you know that this is x to the power of negative 2. When you solve it slowly, it's x times x over x times x times x times x times x, which means one over x squared. So 1 over x squared is actually x to the power of negative 2. So this says that the rule for indices, x to the power of negative m equals to 1 over xn. Now the summary of index laws. xm times xn gives you xm plus n. When you multiply the terms, you add the indices. xm divided by xn is xm minus n. To divide, subtract the indices. xm power to n gives you x to the power of n times n. When you find the power of a power, you multiply the indices. X to the power of 0 gives you 1. Any value to the power of 0 equals to 1. Lastly, x power of negative m gives you 1 over x to the power of m. That's a condition when x is not 0. Because when x to the power of 0 is still 1. Fractional indices. x1 over 2 times x1 over 2 gives you x1 over 2 plus 1 over 2, which is x power of 1, which is x. And in order to understand what x to the power of half means, you ask yourself what number multiplied by itself will give x. The answer is root x times root x gives you x. So x to the power of half is root x. Similarly, y to the power of 1 over 3 times y to the power of 1 over 3 times y to the power of 1 over 3 gives you y to the power of 1 over 3 plus 1 over 3 plus 1 over 3. This gives you y to the power of 1, which is y. And again, what number multiplied by itself and then by itself again will give y. So y to the power of 1 over 3 is cube root y. This shows that any root of a number can be written using fractional indices. So x to the power of 1 over m is m root x. Lastly, there are different ways to write the expression. So x to the power of 2 over 3 can be written as x1 over 3, 2. Because 1 over 3 times 2 is 2 over 3. Same thing here, y to the power of 3 over 4 can be written as y to the power of 1 over 4 times 3. You already know that a unit fraction gives a root, so we can rewrite these expressions in root signs like this. And here. In general terms, x m over n can be written as x times 1 over n equals to x 1 over n power of m, which also means. So that's all for today. Thanks for watching, and if you have more questions or you hope for more details, please feel free to comment down below to let us know. Here's our social media platforms that you can use to contact or make inquiries. And we are currently looking for volunteers to be chat respondent or video maker. So if you're interested, please feel free to email us at project.study.buddies@gmail.com. Thanks for watching and have a nice day.